So here we are, question number 5. This is a little bit more involved of a question, simply because we need to use some of our formulas that we've already learned. So here we have a coordinate plane with a triangle that's been graphed, and we're given the vertices. So point A is at 6, 0. I'm just going to label them on the graph. Point B is at -2, 2. Point C is at -3, -2. And we're asked to find the perimeter of the triangle first, and we're going to need to round to the nearest hundredth. So that tells me we're going to have some decimal answers here, and the perimeter is where we add up all the sides. So we need to find the lengths of all the sides, and whenever we find length, we're going to do that using the distance formula. So we're going to take and subtract our x's and square that number, subtract our y's and square that number. So for each side, we're going to have to do the distance formula, and then we'll add all the numbers up together. So I'm going to find the length of AB, and that is going to be, so I'm going to have this be x2 and x1. So I'm going to go 6 minus -2, and then I'm going to go 0 minus 2. So 6 minus -2, that's 8. 8 squared, and then 0 minus 2 is -2, and -2 squared. So 8 squared is 64, and -2 squared is 4. So that's going to be the square root of 68. So when they're talking about decimals, that is going to be a decimal. So I'm getting out my iPhone calculator, and I'm going to use, when I turn it to the side, so I'm going to go 68, and I'm going to use the square root button. So that's 8.25 if I round it. So one side is 8.25, and I'm going to do the same thing for BC, and I'm going to take, and I'm going to make this x2 and x1, so I'm going to go -3 minus -2, and -2 minus 2. So -3, add the opposite, minus -2, that's going to be -1 squared. And -2 minus 2, that's -4 squared. Now if you're using a TI or however you're doing this, just make sure you're either putting the number in parentheses, or in your head you're going -1 times -1 is +1. And then -4 times -4 is +16. So we get, and I don't want to write all over my drawing there, so we get the square root of 17, and then I'm using my calculator again to get that as a decimal. So that's 4.1. So I can label that here. 4.1 is the length of side BC, and then side AC is the last side, and I'll use the -3 as point x2, so I'll go -3 minus 6 squared, and then -2 minus 0, which is just -2 squared. So we get -9 squared, which is, I'll write it out, -9 squared and -2 squared. So that's 81 plus 4, square root of 85. So I'll figure that out in my calculator. The square root of 85 is 9.2. So when I add those all together, 9.2 plus 8.25 plus 4.1, I get 21.55, and that is slightly different from what is in the answer key. So they must have rounded slightly different. They get 22.59. So let's see, did I make a mistake? -3 plus I think maybe I just rounded to the nearest tenth here instead of the nearest hundredth, so that got me a little bit off. So let me just double check those again. Square root of 17 is 4.12. Square root of 85 is 9.22. So now I get 21.59. So the answer key may be off by 1 unit. So we'll just leave it at that. And now we need to find the area of the triangle. Now, the area of a triangle, there's a couple of different formulas, and when we study our area unit, we'll do things a couple of different ways. The first is an area formula that we've already used in our ACT practice, 1/2 base times height. But this only works if our two sides are meeting at a right angle. Okay, so I'm going to do a quick check to make sure that these lines are perpendicular before I go ahead and use this formula, because I don't want to use the base and the height if they are not perpendicular. So I'm going to do a quick slope formula on line AB. So I'm going to subtract my y's, 0 minus 2. So remember, slope formula, let me write it over here, is y2 minus y1 over x2 minus x1. So I'm doing 0 minus 2 and 6 minus negative 2. So I get negative 2 over 8, which reduces to negative 1/4. And then let me find the slope of BC. So that's the slope of BC. And so now I'm going to go negative 2 minus 2 on the top, and negative 3 minus negative 2. So that gives me negative 4 over negative 1, which is 4. So remember, perpendicular lines have opposite reciprocal slopes. So if I've got a negative 1/4 and a positive 4, those are opposite reciprocals, which means they're perpendicular, which means I've got a base and an altitude or a height. So now I can use my formula, 1/2 times 8.25 times 4.12. And let me work that out. It's 4.12. 8.25 times 4.12, and then I'll divide it in half, and I get 16.995, which I'm going to round to 17. And when we do areas, we do square units. So it'll be square feet or inches, and since these are on the coordinate plane, they're just plain units. And then last but not least, we've got the directed line segment problem. Oh, this is a whole different problem. So we're not using this graph anymore. So I'll just go ahead and work this one out in this same video. So remember, directed line segment, we are going from 0,3 to 6,9, and we're dividing it in the ratio of 2 to 1. So we are going to use the formula for the horizontal component and the vertical component. So remember, my horizontal, that's going to be with the x's, and we're going to take our k fraction. So remember, to get k, we want to compare the part to the whole. And so here I've got 2 to 1, so the part is 2, and then for the whole thing there's 3 parts. So I'm going to multiply 2/3 times x2 minus x1, and then I'm going to add back x1 again. So 2/3 of 6 is 4, and 4 plus 0 is 4. Then to do the vertical, I'm using my k value again, and now I'm going to do, so this was x2 minus x1 plus x1. And then here is 2/3 times y2 minus y1 plus y1. So y2 is 9, and y1 is 3, plus y1. So 9 minus 3 is 6. 2/3 of 6 is 4. 4 plus 3 is 7. So the ordered pair of the point would be 4, 7. Now, some of you still struggle with this and the formulas don't make any sense to you, so I'm just going to sketch this out a little bit. I wish I had a piece of graph paper here, but I'm going to go ahead and just sketch this. So here is a coordinate plane, and I need to go, my highest point on the y's is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the x's, I need to be at least 6. 6. So 0, 3 is here, and 6, 9. 1, 2, 3, 4, 5, 6, and 9 is up here. Okay, so let me connect that with my ruler. Now, if I was, so 0, 3, and 6, 9. So if I went over and I cut this thing into 3 pieces, if I was going to have a ratio of 2 to 1, so here's a piece, here's a piece, and here's a piece. So if I want a ratio 2 to 1, I'm looking for the location of this piece right here. So the fact that I got 4, 7, that tells me the location of the dot that's 2/3 of the way on the line. So we just have these formulas here to help us so we don't have to draw a picture every time. So that's questions 5 and 6. Those are review for you guys. So let me know if these videos are helpful or if you have any extra questions.